Hey, welcome back. So we're going to take a look at another vector question. And this is again a calculator question. And if the AP says you can use a calculator, you best use that darn calculator. And again, I am going to be using my TI Inspire CX my CAS. One of these days, I might get sponsored by TI since how much times how good I talk about it. All right. So in this case, we have an object moving along a curve in the XY plane, and again, they give us the position. This is a vector question, I can tell, because again, I'm given a parametric equations with t at time t. So good. All right. Now, then they give me these equations right here, dx dt and dy dt. Now remember, this is my position, which means these two equations, they're really ugly. I can tell it's a calculator because that's how ugly those are. But here they're giving us the velocity vectors. And we're only talking about time between 0 and 2. So we're not talking about a whole lot of time here. And then they say at time t equals 1, the object is at this point. So when I look at something like this, I'm thinking FTC. They gave me a derivative, and they're giving me a point. I'm thinking fundamental theorem. All right. So let's try this. This is an AP style question. So question number A. Find the equation of the tangent line at t equals 1. Okay, it's a tangent line. We can do tangent lines. We need a point, and they did give us that point, 3, 2. Next, we need the slope. Well, it's a parametric equation, so to get the slope, dy dx, that's just y prime of t over x prime of t. And they tell us that. This is going to be cosine e to the t. Whoops, terrible, other way around. There we go. It will be sine e to the t over cosine e to the t. Now, we want this at t equals 1, so we just get sine e over cosine e. Please don't cancel out the e's right there. That would be bad. Now, if you want to, though, you can write this as tangent e. Now, if you don't have a calculator, you can leave it like this. But if you have your calculator on, you can leave it like that. The AP will be fine with that. But let's go ahead and calculate what that is. I'm going to go do the tangent of e to the first. Press enter. Oop. So I'm going to convert this to a decimal. Hit Control Enter. And we get negative 0.451. So my tangent line, y minus 2 equals negative 0.451 x minus 3. And there's our tangent line. Quick and easy. All right. Part B, they're talking about find the speed of the object. Now, in our last example up here, our first example up here, to get speed, remember, speed is the magnitude of velocity. And we use the Pythagorean theorem to calculate that. So you take a look at that video. This is video number 1 on this section here. So we can get that speed by looking at the magnitude of our velocity vector. And remember, this is a formula. Just x prime of t squared plus y prime of t squared. And if I do this, and I'm looking for at t equals 1, so I'm going to need the derivatives. So my magnitude equation is going to be this. If I take their derivatives, we would get cosine e to the t squared plus, got to take their, might as well take their derivatives. Oh, they gave me the derivatives. Oh, I was on the right track there. There we go. There we go. So these are the derivatives already. Excuse me. So this would be the cosine of e to the t squared plus sine of e to the t squared. And again, we want to evaluate this at t equals 1. And this is really not that bad to do. Honestly, you should be able to do this one without a calculator, because this is just cosine squared plus sine squared. So, and if you want to, you can say this. What is the cosine of e squared plus the sine of e squared? Well, again, this is just cosine squared plus sine squared, which is 1. This is square root of 1, which is going to be 1. Now, we do get plus or minus, but speed is a magnitude, so it's always positive. So you get the plus or minus, but because it's a magnitude, we always take the positive one. All right, so for C, find the total distance traveled. And again, up here, in the first example that we did together, or another video, please take a look at it. To get distance, we just integrated our velocity, our magnitude vector, the magnitude of our speed, or get our speed, times the change in time. So for distance, to get the distance, our formula is we're going to integrate from A to B. This is my speed. Speed times time gives me that change in that distance. So my speed times my time gives me my distance I travel. We have to integrate it because remember we're talking about really small incremental changes in distances here. So setting this up. You know what? Not working there. There we go. So we want to go from 0 to 2. So we go from 0 to 2. The square root of, again, my derivative is already done. This is cosine e to the t squared plus sine e to the t squared dt. And we just type this in our calculator right here. Menu 4.3, excuse me, escape. Menu 4.3 for the integral. I'm just going to type this in. 0 to 2. Square root. It's a calculator question. Use your calculator. You can't integrate this by hand. It's too messy. Type in the first one in. It is the cosine e to the, I'm going to use x. You can use t. I guess I can use t. Let's use t this time. T squared. Whoops, not 4. Squared plus, do the same thing with sine. Sine e, and again, I'm going to use t again. I just have to make sure I use my same variable. Oh, got to square it first. Square it first. I just got to make sure I use my same variable out here, t. And I press enter, and we just get 2. How boring is that? And of course, we should expect this to be 2, because we should be able to integrate. I mean, again, sine squared plus cosine squared is 1, right? I mean, if I want to do it by hand, this is just the integral from 0 to 2 of 1 dt, which is just t from 0 to 2, which is 2. But they tell me I can use a calculator. Why not use it? All right, the last part. All right, D. Now for part D, we want to find the position. Here's our FTC question that I warned you about earlier. So here's our FTC question. So now we want to find the position. So because we're looking for the position here, and this is a parametric, we have to treat x and y independently from each other. So the first thing we're going to find is x of 2. I'm looking for the value at x equals 2. So to get the position, we know we have to integrate. So remember, I have to get position, we integrate velocity. So for my x of 2, it's going to be for my x1 from 0, oops, sorry, not from 0. All right, I'm still not working there. There we go. From 1 to 2. Now we're going to plug in our x1, cosine of e to the t, dt, and that's going to go from x of 2 minus x of 1. Remember, this right here gives me my change in my x values. And again, I'm just going to type that in my calculator. Calculate. Menu 4.2. Keep doing that. Menu 4.3. Sorry, my old CX was menu 4.2 to get to the integral. 1 to 2. And we just integrate our cosine e to the t. I'll use t again. Why not? Just use t right here. Press enter, and I get this negative 0.104. I guess I can leave it there, rounding. X of 2 is what I'm looking for, and they know x of 1 because they told me that earlier was 3. So I know that this is 3. So minus 3. So x of 2, and if you simplify that, you get 2.8 2.896. And I do the same thing for the y's. Y of 2 would be the integral from 1 to 2. My change my y integral for y. Sine e to the t, my derivative there, dt. So again, this is my change in my y values. That's going to equal y of 2 minus y of 1. Now, if you use f and f, f2, f1, we're okay with that. Should use y, though. And I integrate here again, menu, 4, 3, did it right that time, 1 to 2, sine e to the t. Since I'm using t, I'll use t again. Press enter. And this time I get negative 0.324. So what this tells me? That during the time between 1 and 2 seconds, we lost, or we went down, 3.24 units. Y of 2 is what I know. Y of 1, they tell me that, is 2. We know that from the beginning, again. T equals 1. My y value is 2. So minus 2. So we get y of 2 equaling 1.676. Now don't leave your answer this way. Write your answer as a point. And you can write the point as a vector, so we'll do 2.896, 1.676. You can write it as a point, or if you want to do your vectors, you can do that too. Alright, hope you enjoyed this video, and I'll see you guys later. Bye-bye.